let's talk about security. Because let's face it, work isn't a place you go anymore. It's just the thing you do, wherever you happen to be. And that's awesome. But it also creates a huge problem. When your office has no walls, how in the world do you keep it safe? I mean, really think about it for a second. Your office could be your kitchen table, a coffee shop, or some airport lounge. Your team is logging in from everywhere on every kind of device imaginable. This new reality just completely shatters the old way of thinking about security, and it leaves us with one massive question. How do you protect a workplace that literally has no borders?
You know, the old security model was pretty simple. It was basically a castle with a moat. You'd build this really tough perimeter around your office network, and anything that was inside was automatically considered safe. But today, with all our data living in the cloud and our users scattered all over the globe, that moat is completely useless. An attacker can get inside with just one stolen password. And if your security is still set up to trust everything on the inside, you are in for a world of hurt.
Okay, so if the old castle and moat model is broken, where do we even start? Well, we start by answering a really fundamental question. When you move your stuff to the cloud, whose job is it to keep it all secure? Is it your problem, or is it the cloud provider's? The answer is, it's both. It's a partnership, and this is actually formalized in something called the shared responsibility model. It's basically a framework that draws a clear line in the sand, spelling out exactly which security tasks the cloud provider handles and which ones are always on you. And this chart here shows you exactly how that responsibility shifts. So way over on the left, if you've got your own servers in your own building, you own everything, from the physical door locks all the way up to the data itself. But as you move over into the cloud, from infrastructure as a service to platform as a service, all the way to software as a service, like your email, you can see the provider takes on more and more. But pay close attention to the top of the chart. Notice what never ever shifts to the provider. That's right, you always own the security of your data, the identities of your users and how they get access, and the endpoints. We're talking laptops, phones that connect to your services. Look, a cloud provider will secure their platform, for sure, but they can't protect you from a terrible password or a laptop that gets a virus. That part is on you, period. So we know who's responsible for what. Now, let's talk strategy, because modern security isn't about building one single impenetrable wall. It's about creating multiple, overlapping layers of defense. The strategy is called defense in depth. And honestly, the best way to think about it is like a super high security bank vault. A robber doesn't just have to get through one door, right? They've got to get past guards and cameras and keypads and then the main vault door, and then they still have to crack individual safe deposit boxes. Every single layer just slows them down and dramatically increases the chance they're gonna get caught. In our digital world, the layers look a little more like this. It starts with the physical security of the servers, and it goes all the way inward to the data itself, which is the prize. You build controls for people's identities, for the network, for the computers, and for the apps. The whole goal here is that if an attacker manages to break through one layer, let's say they steal a password, the next layer is waiting to stop them dead in their tracks. So what is the whole point of all these layers? What are we actually trying to achieve here? Well, it turns out that every single security control, no matter how complicated it seems, is designed to protect one of three things. And this framework is known as the CIA triad. And no, it's not that CIA. In our world, C stands for confidentiality, which is all about keeping secrets secret. Simple enough. I is for integrity, making sure the data is accurate and hasn't been messed with. And A is for availability, making sure you can actually get to your systems when you need to. A truly good security program is in a constant state of balancing these three goals.
Okay, we've covered who's responsible and the strategy of using layers, but now let's talk about the philosophy, the big idea that ties everything we do in modern security together. It's a pretty radical shift in mindset, and it is perfectly designed for this borderless world we live in.
This simple motto is the absolute core of what we call the zero trust security model. Instead of just assuming a request is safe because it's coming from inside the network, you assume nothing is safe. You demand proof from everyone and everything, every single time, no exceptions. This whole philosophy is built on three guiding principles. First up, verify explicitly. That means you always check identity, location, the health of the device, and a bunch of other signals before you grant access. Second, use least privileged access. You give people only the bare minimum access they need to do their job, and only for as long as they need it. And third, and this one's a big one, assume breach. You design your systems with the assumption that attackers are already in, and you focus on minimizing the damage they can do. So, putting this into practice means treating your entire digital world, your identities, devices, apps, networks, as sources of information. Every time someone logs in or tries to access data, it sends a signal. A modern security system acts like a central brain, constantly analyzing all these signals in real time to verify trust and automatically block threats, hopefully before they can do any real damage. All right, we've got our philosophy, our strategy. Now let's get a little more practical. What are the actual tools we use to build all these defenses, and what are the rules that govern how we use them? The most fundamental tool in the entire security toolbox is encryption. It's just the process of scrambling data so that it's completely unreadable to anyone who doesn't have the secret key to unlock it. This means if an attacker manages to steal an encrypted file, all they've got is a bunch of useless gibberish. Now, encryption comes in two main flavors. You've got symmetric encryption, which uses a single key for both locking and unlocking. It's super fast, great for huge amounts of data. Then you have asymmetric encryption, which uses a pair of keys. A public key that anyone can use to lock the data, but only you, with your private key, can unlock it. This is the magic behind how secure websites work. Now, what about passwords? For those, we use a special one-way process called hashing. But just hashing a password isn't really enough anymore. To do it right, we use a clever technique called salting. Before the system hashes your password, it adds a unique, random value. That's the salt. This little trick ensures that even if two people have the exact same password, their stored hashes will be totally different, which makes them way, way harder for attackers to crack. So all these technical tools are absolutely essential, but they can't just operate in a vacuum. They have to follow a set of rules, and that's where governance, risk, and compliance, or GRC, comes in. Think of this as the high-level rulebook that organizations use to define their security policies, manage threats, and make sure they're following all the laws that apply to their business. And within that compliance world, there are a few key ideas you've got to know. Data residency is all about where your data is physically stored, which country. Data sovereignty is about which country's laws apply to that data. And data privacy is about the rights of individuals and the rules for handling their personal information. For any global company, these rules shape pretty much every single security decision they make. So as we wrap this up, it really all comes back to this one simple question. In a world where work happens everywhere, clinging to that old castle and moat security model isn't just outdated, it's a recipe for disaster.
In a world where so much of what we do is online, proving who you are is literally the foundation of, well, everything. So let's dig in and see how that foundation is actually built and protected. I mean, just think about how we all work these days. That traditional idea of everyone sitting inside one single building, all nice and protected by the company firewall, yeah, that idea is completely gone. The modern office, it's not a place anymore.
It's you on your laptop, maybe at a coffee shop. It's a colleague accessing a shared file from halfway across the world, probably on their own phone. It's this, huge, sprawling, interconnected web of users and devices all over the place.
So that leaves a pretty big question, right? If there's no front door anymore, who's guarding it? If that old security model is totally broken, what on earth replaces it?
Well, to get to the answer, we first have to understand why that old model totally fell apart. We need to talk about this idea of the security perimeter and why, for all practical purposes, it's basically just vanished into thin air.
So the old way of doing things was super simple, right? It was called the castle and moat. You'd build these huge digital walls, firewalls, around your company network to keep all the bad stuff out. But this model just completely falls apart in today's world. When your apps are living in the cloud and your team is working from literally anywhere, those walls are just meaningless. There's no inside to protect anymore.
And that, right there, is the fundamental shift. If the network can't be the boundary anymore, then our identity has to become the new perimeter. The whole question changes from, hey, is this request coming from inside our network? To, is the person or the device making this request actually trusted? Every single decision about access now starts with identity.
Okay, so if identity is our new guard at the gate, we've got to understand the two main jobs it has to do. They sound kind of similar, but they are critically different. Authentication, which we call authn, and authorization, or auth-z.
The best way to get this is the hotel analogy. It's perfect. Picture this. You walk up to the hotel front desk and you show them your passport. You are proving you are who you say you are. That is authentication. It answers the question, who are you? Then they hand you a key card. Now, that keycard doesn't open every door in the hotel, right? Just your room, maybe the gym. That is authorization. It answers the question, what are you allowed to do?
And that order is everything. It's non-negotiable. You always have authentication first. A system has to know for sure who you are before it can even think about what you're allowed to touch. You can't get the keycard until you've shown your passport. Simple as that.
Okay, but imagine for a second if every single app you used, your work apps, your personal apps, had its own separate login, its own security rules. It would be a total nightmare to manage, right? That's exactly why modern systems centralize this whole process with one single trusted service.
And that's where an identity provider, or an IDP, comes in. Think of it as the central security hub for everything. Instead of each app keeping its own list of users and passwords, they all just point to and trust the IDP. This makes security consistent, and even there, it gives us that amazing feature we all love: single sign-on. You log in once to your IDP and boom, you get secure access to all your apps.
So a really solid identity system is built on these 4 pillars. You've got administration for managing all the accounts, authentication for proving who you are, authorization for deciding what you can do, and auditing to keep track of everything. But wait, for any of this to work, all this information, it has to live somewhere, right?
And that somewhere is what we call a directory service. You can just think of it as the master guestbook for the whole organization, the official record of every user, every device, and all of their permissions.
For like decades, the gold standard was something called Active Directory, or AD. It was like a real physical guestbook kept behind the front desk. It was designed for a world that was all self-contained. But today, the new standard is a cloud-based service like Microsoft Entra ID. Now this is more like a global, cloud-synced reservation system. It's built from the ground up to be securely accessed from anywhere on the internet, and it can connect to any modern app you can think of.
All right, so that's all great for managing people inside your own company. But what happens when you need to work with someone from another company? How do you securely cross those digital borders without having to create a bunch of new accounts and passwords?
Well, the answer is a really cool concept called federation. Basically, it's a way for 2 different companies' identity systems to create a formal trust relationship. Your company's system says to a partner system, hey, we vouch for our people. If we say this person is who they are, you can trust us.
The passport analogy is seriously the best way to think about this. Your passport, it was issued by your home country, right? When you travel, another country doesn't make you prove your identity all over again. They just look at your passport and accept it as valid. They trust your home country's process. Federation is the exact same idea, just for digital identities. Your home organization vouchers for you, and the other organization trusts that voucher.
And here's the thing, you use federation constantly, probably without even thinking about it. Ever had to access a partner company's website using your normal work login? That's federation. And even more common, you know when you see a sign in with Google or sign in with Microsoft button on a new app? That's federation too. The app is just trusting Google to be your identity provider.
And that brings us right back around to the single most important idea in all of this. In our modern, borderless world, security is no longer about where a request is coming from. It is all about verifying who or even what is making that request. Identity isn't just part of security anymore. It's become the ultimate control point. So here's the final thought. If our digital identity really is the universal key to pretty much everything we do online, who should we trust to hold it?